Hi everyone, welcome to this video. In this video we're gonna be checking out computation problem. The problem statement is we'll be given a linked list and we have to check or determine whether there exists in a loop or a cycle in a linked list. So what I meant by a cycle or a loop means, if we say this, if we take this first example, over here we can see that we have five nodes and one is pointing to 2 and 2 is pointing to 3, 3, 4, 4 is 5 and 5 is pointing to 2. So if we start traversing this linked list all the way from the first node, which is head, when we reach 5, we will be going to the second node again. And second node, we'll be going to 3 and we'll be going eventually going to 5 and 5 and 5 will be going to 2. So we'll be in this loop forever. So then we can say that this linked list has a cycle or a loop because we are forever reaching the same we are traversing some of the nodes again. So then we can say that we are in a loop. There is this a loop or a cycle in the given linked list. Whereas if you see the second linked list, if you start traversing the linked list from the first node, which is head, we'll be reaching the last node. There is no loop or cycle in this linked list. When we reach the last node, the next node which is pointing to is a null. There is no node which the last node or the tail node is pointing to. So then we can say that this linked list doesn't have any loop or a cycle. Yeah, so basically our algorithm which we have to write should detect whether there exists any cycle as such or a loop in the given linked list or not. If so, we have to return true. If not, we have to return false. Yeah, now that we have understood the problem statement, we'll be solving this problem using two approaches. In the first approach, we'll be detecting the loop using a hash. Over here, I have written the solution in Java programming language. So we'll be discussing the algorithm. The algorithm is the same, but the Java computation program is different in different programming languages, right? So first we'll start by discussing the algorithm. So in this approach, we'll be using a hash set to store the nodes which we have traversed. So for that, first we will be traversing the linked list with the condition that the node is not equals to null. And inside the loop, we will be checking whether the node which we are in currently is already in the hash set or not. If it is already in the hash set, then we will be returning true, saying that we are in a loop, which depicts that we have already encountered the same node again. If this node is not in the hash set, we'll be adding it. And at the end of this loop, we'll be returning false because this loop will basically essentially stop when the node which we are pointing to or when the node which we are pointing to is null. So it means that we have reached the end of the linked list and the link node which is pointed by the tail node is null basically. So that's why we are returning false. So this is the computer program for this algorithm. This is written in Java, as I said. Over here, this is the core method of our algorithm, detect cycle. So this basically takes the linked list node, which is a head node, as a input. And in the first line, I have created initialized a hash set, and then I have been starting the loop, while loop. Over here I'll be this while loop will be only running until this head is not equals to null. And over here I am traversing from the head node to the next node, and followed by I am checking whether the current node which I am in is already existing in the hash set or not. If so, we are returning true. This says that we have encountered the same node again. If not, we'll be adding this node. So whenever if we encounter the same node again, as we have already have added this node to the hash set over here, this condition will be true and will be returning true, and the this method stops. And at the end of this, after this loop is ended, I am returning false because basically this loop will start only when this head is equals to null. So when we are in the last node, if there exists no loop, the head dot next will basically be null. So it means that there is no such loop or cycle in the given linked list. So we will be returning false. Yeah, so this is the computer program for this algorithm where we have written the solution using the hash set. So if we examine the time complexity and space complexity of this algorithm, so here this basically this while loop will be running as many times as the length of this linked list. So we can say that the time complexity is big of n, where n is the length of the linked list. And for in case of space complexity as well, here or here we are populating the hash set, right? So for every node of the linked list we are adding this node to this hash set. So it means that we can say the space complexity is big of n, where n is the length of the linked list. Yeah, so this is all about the first approach where we have detected the loop in the linked list using the hashing. Now if we move on to the second approach, so over here we'll be detecting the loop in the linked list using a fast and slow pointers technique. Yeah. So in this approach, basically first we'll start by initializing two list node variables. We can name it as fast and slow. So and we'll be starting a loop. So in the loop, we'll be the slow node will be moving one step at a time, and the fast node will be moving two steps at a time. So, and inside the loop, if fast node ever meets slow node, will be returned true. It means that there exists a loop because fast node, as we had discussed, fast node will be moving two steps at a time, and slow node will be moving one step at a time. So, in case if fast node is meeting slow node, it essentially means that there exists a loop. If there no loop, the fast node will not meet this slow node ever, right? Fast node will basically go to the end and it will stop. Yeah. So and the after this while loop, I'll be returning false because this while loop basically will be running only when slow node is not equal to null and also fast node is not equal to null, and also this fast dot the next of the fast node is not equal to null. So when either of this is true, it means that we have reached the last node, and the node which is pointed by the last node is basically null. There is no node which is pointed by the tail node. So that's why we will be returning false. So this is the computer program which is written in Java programming language for this algorithm. Or here, this is the method which takes linked list node as input. Basically, this is head node. Over here, I am initializing two list nodes. One is named as slow and other is named as fast. Both will be starting with head node as the value. And here I'm starting a loop, inside which we'll be moving slow pointer one step at a time and fast node two steps at a time. Basically, this loop will only be running or executed only when slow node or fast node is not equal to null, and also the node pointed by the fast node is also not equal to null. Yeah. So that's why after this while loop, I'll have been returning false. This means that essentially we have reached the end of the linked list, and the end node is pointed to a null. There is no node which is pointed by the tail node. And inside the same loop, have been checking, we'll be checking whether the fast node is meeting slow node or not. If there exists any loop, definitely fast node will be meeting a slow node, right? So that's why we'll be checking this and returning true. So if you want to understand it in a clear way, you can think of example of two runners in a running track. So both will be running at two different speeds. The one who is running fast will eventually meet the slow node again after completing a loop, after completing a lap, right? So that is the same. This algorithm also executes the same idea. Yeah. So this is the Java programming language. This computer program is written over here. So this is all about this second algorithm. So if we examine the time complexity of this solution, so the maximum number of times of this loop will be in case when last node is pointing to a last before node. If there exists a loop between last node and last before node, then in that case we'll be going through the worst time complexity. So in that case, the number of loops, the number of iterations will be as long as the number of nodes in the linked list. So as because since we are moving slow pointer one step at a time, right? In order to meet fast pointer, it has to travel all the way to either last node or last before node. Yeah, so that's why we can say that the diagonal complexity of this algorithm in terms of big O notation is big O of n, where n is the length of linked list. And space complexity is a constant because over here we are not creating any dead sections and populating it, right? Yeah, so this is all about the second approach. So in a nutshell, we have solved this problem of detecting a cycle or a loop in a linked list using two approaches. One is using hashing and other is using a fast and slow pointers technique. The advantages of second approach over first approach is we have observed a better space complexity in case of second approach when we compare it to the first approach. Yeah, so I'll be leaving the link of this sheet which I'm displaying over here in the description of this video, so feel free to go through this. Yeah, so that's it for this video. See you in the next.